So in the previous lecture, we discussed R data types and R data structures. Data types include logical, so true, false, and then numeric, either integer or real or complex, and then string, or also known as character. Data structures include vectors, which we use often, list matrices, which we use less often, data frames, which we'll get to in the next lesson, and factors. So a vector is a one-dimensional array, and last time we mentioned all the elements in a vector have to be the same data type. So for instance, they can all be numbers or they can all be character strings, but not a mix. It's important to note that if you do perhaps give R a mix of, say, numeric and character, there's a set hierarchy in R for type conversion. So if you, for instance, let's have a look in RStudio, try and make a vector with both numbers and characters, and there you can see the 9 is a character, R will actually go and convert your whole vector to only characters. And that's because numeric gets converted to characters in R. So that's important to remember. So let's have a look at subsetting and extracting values from vectors. So for this we use the square brackets in R. So don't get confused between the curved brackets and the square brackets. So these ones are always for a function, where square brackets are always for subsetting. So if we look at that weight underscore g variable we previously created, say we only want the first element of that object. Then we're going to make a square bracket next to the variable, no space in between, and say 1 for element 1. If we command enter that, then it gives us 50, which is the first element of that list. And then you can also select a range of elements. Say you want elements 1 to 3, then you can use the colon, say 1, 2, 3, and you see that gives you the first 3 elements. Another way of extracting set values from vectors is to use conditional subsetting, and we've got the larger than, smaller than, larger than or equal to, smaller than or equal to, which you see is 2 equal signs next to each other, not just one, which is used for assignment. The or operator, and the exclamation mark, which means not. So let's practice some conditional subsetting. So here's an example where we're going to use the larger than sign to subset our weight variable. So maybe we're only looking for entries that are larger than 50. So if you just say weight underscore g larger than 50, what R is going to tell you is whether that is true or false. So the first entry is false because 50 is not larger than 50, and then for the remaining 3 it gives us true. But maybe we actually want those values returned based on our condition. What you would do then is say weight underscore g and then use your square brackets, which is for subsetting, and then put your condition inside the brackets. And now you can see it gives you the actual values back that are bigger than 50. And then you can also combine conditional operators. So we use the larger than sign, but you can maybe also use the or sign in the same assignment. So if we have a look at this in R, and I'm just going to edit our variable a bit so it has values that are actually smaller than 50. Run that. So now what we're asking is, for weight g, please give me all the entries, and for that we use our square brackets, where weight g is either smaller than 30 or weight g is larger than 50. So there you see the return. It'll give us the 20, the 25, but not the 50, and again the 60, the 65, and the 82. So it's often quite useful to look for character strings in your data. So maybe if we look at this animals one that we made previously, and we're only looking for entries that are either cat or rat, so you'll see in our example we actually didn't have a cat entry. So if we ask for of animals, please give me entries that have either cat or rat, then it'll only return the rat entry for us. If we try an and there, it'll give you character 0, which means it doesn't return anything because there are no entries that are cat and rat. So in this instance, it's appropriate to use the OR operator. And then one function that's really valuable that I use quite often is this little percentage sign, and then in, and then another percentage. So if we do, and this asks which animals are present in this vector. So of my entries here, which of them are also in this vector over here. So you'll see it'll give me as many entries as I have in my animals object. And for animals, we currently have mouse, rat, dog, and horse. So the ones that were true were rat and dog, and you can see they were present in this other vector that we specified. So that gives us true and false. Again, if we want the actual data returned, we'd have to use our square brackets for subsetting. So we'd start with animals, square bracket, and then you literally take this syntax here, put it in the square brackets, and you can see now it gives you rat and dog instead of true and false. So you'll see there's another little challenge here in the data carpentry course material that you guys can go puzzle over. But for now, let's go on to missing data. So missing data is very relevant to clinical research. I often have columns of a specific clinical variable, and then maybe for some patients they just didn't have that information. So in that case, what R recognizes there is the NA. So it's not an NA with inverted commas like a character string. It's actually a built-in data type in R. So it's important to note that NA is not the same as NA in inverted commas or N/A. And this is something that's very useful if someone is supplying you with an Excel sheet with clinical data, and to tell them this while they're creating the data so that you don't have to go pick out and make sure all their NAs are consistent throughout. Then there's some useful functions in R. You might find that you need to pull out only entries that don't have NAs. So let's look at some examples in R Studio. If we tweak our animals object and maybe we add an NA entry. So now we say is.NA animals, you'll see it'll give us false, 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 and true. So the last one is true. One that I find very useful is complete.cases animals, and that's just the opposite. So by that you can use to actually subset. So if I then do animals complete.cases animals, it'll just take out that NA and give me mouse, rat, and dog. And now I just want to quickly touch on factors, which you'll encounter very often in R. So factors are categorical data. So they're a predefined set of unique values, and in R those are called levels. So you might have a factor with male and female, where the levels are male and female. So factors are by default alphabetically sorted, And you can use the relevel function in R to change if necessary. Sometimes you have a plot and you require a specific order for different subplots, and then the relevel function is quite handy. And then one thing that I just want to highlight is that sometimes when you import data into R, and we'll be practicing that in the next lectures, R might read your data that you meant as numeric as factors, and that is if they might look like character strings. So when you are in R Studio and you think you've imported your numeric data, R might be seeing that as factors. I'm going to show you an example why that can be dangerous. If we look at our weight_g variable, and we make a new variable where we convert weight_g to a factor, for that we'll use the as.factor function. And let's look at what's happened to that object now. So as you can see, we had the 20, 25, 50, that stays the same. But now what it says at the bottom is levels. So R is actually reading this as categorical data, not numerical data. And if your data has imported into R like this, you might be tempted to just go, okay, I need to convert it back to numeric. Then you go as.numeric, weights, and that factor variable. And you see what happens now. What you may have expected is for it to convert back to 20, 25 and the original values. But R has actually gone and just taken that hierarchy of levels and said, okay, they must be 1, 2, 3, 4, 5, 6. And that can be dangerous, especially if you don't know exactly what your data is supposed to look like. So just be careful with that. Lastly, I've included an additional link with hands-on practice for R data types and structures. So this is from the software carpentry material that's same organization as data carpentry, and you'll see there is kind of a practical tutorial that you can go work through here, and I think it is quite useful to do to get used to different R data types.